All right, so let's get started. We have a lot to cover, so I am going to try to go fairly quickly. If for whatever reason you don't understand what I'm saying or I'm going too quick, just pause the video and go back, and you can always just rewatch. But first off, I'm going to start with some due dates. Uh, Stream macro invertebrate communities, your lab report is due September 21st, so that is tomorrow by 6 p.m. This is just like how it's been, where it's due on the day your lab typically would meet. And so September 21st, tomorrow, is when that is going to be due. Um, every day that it's late, it's -1, so make sure to get that in. Next up, we have the vegetation organization. This is the lab we're going to be doing today. Your hypothesis should be submitted by 9 p.m. today, which you all should have already known. But if you happen to watch this video and haven't done it yet and it's still Sunday, make sure to submit that. The actual lab report for this exercise is going to be due September 28th. And one thing that's a little different is your quiz is going to be due Friday, September 25th by 9 p.m. Now the quiz, let's click on the actual module. The quiz is going to be based off of the first exercise. So the first exercise is not what we're going to be actually doing. What we're going to be doing is this online exercise. The one that's here is what we would have been doing if we would have met face to face. However, because we're not doing that, we're switched to an online version. So you do have to actually go through this exercise, familiarize yourself with the background to take this quiz. But the quiz is not going to be based off our online exercise. However, your hypothesis should be based off the online exercise, which it says it right here. So there's no excuses for submitting a hypothesis for the wrong exercise. So once again, this is the one that we're going to be doing. So make sure to go in here when you actually want to do your lab report. And so basically what we're going to be doing today is looking at the distribution of plants in a simulation across an ecological gradient. So we're going to be doing 3 transects across these 2 habitats. One is the mesic and the other is a xeric. They're going to be color coded. So the mesic is green and the xeric is yellow/brown. In the middle will be an ecotone, that's just where 2 habitats meet and kind of commingle. We're not going to be worried about that. We're just putting our transect points within the 2 habitats so that we compare the 2. And the ultimate goal here, and what I'm going to be showing you, is to gather our data for the 3 transects, and we're going to be trying to analyze that data in 3 ways. These are the 3 ways. The first one is we're going to be looking at a species distribution across the transects in a graph, which I'm going to show you how to make. Next, we're going to be using a Kruskal-Wallis test to see if there's a significant difference in the alpha species richness of the 2 habitats. And then the third one is another graph where we're going to be creating a species area curve based on the data that we collect. And so if you scroll to the top, if you click here, this is where the actual simulation is. It might take a few seconds to load up. That's normal. It does work slow. All right, so this is what you're going to see when you first get in. The very first thing that you should do, and I encourage watching this video while you do it, because I upload it on YouTube. Hopefully you can pull it up on a phone and then you can work on your laptop following along. So just make sure to always pause if you are trying to catch up, and rewind if I'm going too fast and you couldn't keep up. But yeah, so the first thing that you want to do when you get here is you want to put your sample radius to 3 and your species to 25. So as you can see here, these are the data points that we're going to be making our transect. So we're going to make a transect using these points going directly across. We want 1 through 5 on this side, 6 through 10 on this side, and we want to keep it in as straight of a line as possible and spaced evenly, and we want to make sure that they don't overlap. So to actually move the points, you're going to have to go down here and select the point that you want to move. So I clicked 1, and as you can see, when I click right, it starts to move up here. It is a little bit slow. So that may happen. It may freeze a little bit. Try not to spam it. Just click it one at a time. And so what you want to do is line it up to eventually make a line like this. One thing to note, you don't want it too close, because the way you can check the actual radius is, and this is the way you're going to gather your data, but you would click the point that you want. So sample 1, if you click, this is where the radius. So you don't want this touching anywhere on the outside or on the corners, because as you can see, it goes off and it ends up coming down here. So we don't want that. We want to make sure that our point does not go outside the boundary at all. And when you put another point, you want to make sure that this circle doesn't overlap. So as you're setting your points, make sure to every once in a while click to see where it's actually going to be sampling. And obviously nothing happened there because I haven't moved 2 yet. But if I were to, real quick to show, if I just clicked it, it'll show it. So you don't want any overlap. Now, the save time, I already did mine. And so as you can see, this, you just want it as kind of as straight as possible. I just did it real quick to show you. Now, when you actually go to sample, what you're going to do, so you have your first transect lined up and everything is how you want it. You're going to click sample 1, and it's going to give you numbers here. You're going to grab those numbers, and what you're going to do is, if you go onto here and scroll down to right here, there's a data sheet that you can download. It's the VBL one. They do give options for other ones, but I think this is the easiest. So if you download the VBL one, it will give you something that looks like this. So you have your transect, your plots 1 through 10, and then the 25 different species that you can get, and you have it for all 3 transects. So what you can do is let's decide. And so I clicked sample 1. I'll click that and it'll give me down here numbers. You're going to copy those numbers in. And so just to show real quick, it would be like 5, 4. If it's a 0, leave it blank. Do not put 0. That's very important. So we'll skip that. And so species 4 has 3, then 4, then 1. And then once again, you want to skip all those zeros, leave it blank. 11 had 7. Skip, leave it blank again. 13 had 2. And then that's everything. So make sure that you're looking at the current sample and not your cumulative, because that's going to add up everything. So when you're copying, always look over here. And so if I went to sample 2, obviously these numbers would change, and I copy it down here. And so what you want to do is then keep doing that all the way to 10 and get all your numbers in for this. So after you do that, you will have your transect 1 complete. Now, you don't have to redo the transect. You want to keep the same transect. All you have to do is click replicate. And what replicate does is it clears all your numbers. It keeps the same transect, but it just moves the background. So it's like if we set up a new transect, because everything in the back changed. So then you would once again go and sample, and you'd get your numbers, but this time you would copy them into transect 2. Then when you get everything all the way through 10, you'd go back, you'd hit replicate once more, and then you go through and you sample each one, going through, writing down the numbers in the corresponding plot for transect 3. So that's pretty self-explanatory. I'm not going to sit here and do all 3 transects because that'll take a lot of time. So I went ahead and I already did it. And so when you're done, this is what you should have. You should have something similar to this. And down here, it actually takes the averages of all 3 transects and gives you a summary of your abundance. And so now we're ready to start analyzing some of our data. So I want to have some extra room here, so I'm going to scroll down. And so the first thing that we're going to be covering is species distribution across transect. So what we're going to do that is we're going to highlight all of this and copy it. You can either right click, click copy, or you can do Control C. And then down here, we're going to paste it as values. So do not do Control V. Make sure that you do right click, Control, not Control, right click, paste values. And it will give you something that looks like this. Now you're going to want to go here and grab the row that has this open area and delete it just because we don't need that extra space. And so that gets rid of that. And then once more, you're going to grab it and you're going to copy it. And then down here below it, you're going to right click and you're going to go to paste special. And you're going to go to transpose. All this is doing is changing the layout so that your points are this way and then all your species are going across, because this is how we're going to want it when we make our graph. Now, if you go here and you actually read, which I expect all of you to read all of this over before you listen to this video, but it mentions how we don't want 25 species crisscrossing lines in our figure. We want to limit as much as possible so we can have at least a chance to understand how where each species is, because 25 lines is a lot. It'll look like just a bunch of spaghetti if we do that. So something that we're going to do to kind of cut back is we're only going to use species that showed up in more than 2 plots. So if they showed in only 1 or 2, we're going to get rid of them. And what I mean by that is when you go down here, you can see that here's the plot and each column is a species. If there's a value, then that means it showed up in a plot. So for example, this one had 1, 2, 3, 4, 5. 5 times it showed up. So this one's good. But then we're going to have others where, for instance, 25, 24, nothing showed up here. This one only had 1, this one only had 1. So what we're going to actually do is we're going to go through all of ours and we're going to delete the entire data for those species because we're not going to use them in our graph. So when you highlight it, make sure to click delete and not backspace. If you just hit backspace, it's just going to delete the first cell that you highlighted. So make sure you go and you hit delete. So if you're copying right now, do not copy and just delete those species because I did. You're going to right now pause the video and you're going to actually go in and delete the species that only had 1 or 2 show up for yours, which it may be different than mine. So don't just go off and say, oh, he deleted species 14, so I'm going to. Make sure to only delete ones where, like I said, only 1 or 2 values popped up. If there's 3, they're good. So like this one has 3, we're going to use that. So I'm going to go right now and go through all of them, and I'm going to delete ones that only have 1 or 2. So I suggest that right now you guys take the time to pause the video and do that. And once you do that, you can come back and follow along once more. So I'll go through once more, double checking that everything does in fact have at least 3, which appears they all do. Now, one thing that you can see is now this name from this cell is going over to the other, making it seem like something's here. It's really not. Like if I click this cell here, you can see up here, it's empty. All it's doing is because there's nothing in here, the name continues over. So don't get confused for this next step thinking that there's data here, because there's not. It's just because it's open, they're finishing the name into the other cell. The reason I say that is because now once you deleted all the ones that only had 1 or 2 values, you're going to go in and you're going to grab the actual data So this is an example here. I would not go out to this end because there is nothing here. This is just the name continuing over to the other cell. And you're going to put the data back together. So once again, the Zurich, the pink Zurich is not anything here. We're not copying over any data on this one. It's just the name flowing over. So we put it right next to it. And then once again, we're just filling in all those empty areas now. So once again, Mayflower is not it. That's all empty. What you don't want to do is go like this, because then you're going to cross over some of the data. So we're just putting all of the data back together so that when we do our graph, we don't have to worry about any problems. So once you have all your data back together, if you scroll up, it kind of hints at it that we're going to be doing an XY scatter plot with a line added. So what you can do is go to Insert. You're going to go to Insert XY, and we're going to do Scatter with Straight Lines. Obviously, it's blank because we haven't selected any data, but if you click it and go here under Data, you can then select Data. So we click here, and we're going to do exactly that. We're going to highlight all of our data. Once again, not going to here. That's just the name going over. So we're going to select it, and what we want is, we want on the horizontal axis our plots. So right now, it's doing the opposite. So all you have to do is click Switch Row and Column, and you'll have 1 through 10, and then it has a line for each species with abundance on the side. So you can go ahead and click OK, and we can drag the chart over here. I'm actually going to zoom out so that we can kind of see a little more. And so you want to find this little plus for your chart elements and make sure that you have axes titles. So down here is just the plot number. And over here is the average species abundance. Now, obviously someone will look at this and have no clue what it means because there's no legend. So another thing we have to add is our legend. If you go here, I suggest putting it on the bottom. That way you can extend all of this. You're going to make a pretty big chart. And what I like to do, just to kind of make it look nice, is I'll grab that and I'll just right click. And I'll do outline. Same with back here, I'll just right click, outline, and I'll click black. That way it just kind of keeps it nicer. So let me zoom in so that we can actually see this a little better. So this is almost done. One thing that we want to fix is, because as you can see, the line's just cut off here. So we're actually going to double click this. If you do that, this should pop up. If it doesn't, all you need to do is go to Format Axes, click the bars here, and go to Axis Options. Down here for maximum, we're going to change that to 10. And minimum, we're going to change that to 1. You click Enter, and it should automatically do it for you. And as you can see, now it goes much better. Now, every graph and figure that you make and put in your report, you need to have a figure description. So what we're going to do is we're going to copy and paste this into our actual lab report. On the lab report itself, you're going to end up doing a figure description. In that description, it's very important. You will get points off if you don't do this. You need to mention how plot number 1 through 5 is the Messick, and 6 to 10 is the Zurich. That way, when you actually talk about this, it makes sense that you're describing that pretty much in half. This is the different species abundance across our transect, with that first habitat, the mesic, being on this side and the xeric being on the other. And based on this alone, from my graph, your guys' graph will look different because you're going to have different numbers. You can see that there's a higher species abundance because it's, especially for this one, it goes much higher, and then species abundance is kind of lower on xeric. So that's stuff you're going to talk about in your discussion. All you're going to do for this is get this and put it in your results, and once again have a description with it. You also make sure to change the title. I'm not going to worry about that right now. That's something that you guys can decide on what the title name should be. And this is what you have to do to complete the very first portion of your data analysis, doing your species distribution across transects. Now, underneath each of these analyses are questions. These questions are things to keep in mind when you're writing your discussion to kind of answer. Once again, you're not doing 1, 2, 3, and then giving answers. You're going to, in a paragraph format, kind of discuss your results and what they mean. And these are some questions that you can use to have a better understanding of exactly what you should be putting. So we're going to move on, and we're going to be using our Kruskal-Wallis test to calculate if there's any significant difference between the alpha species richness of the two habitats. Now, to do that, what we're going to be doing is, first of all, you should, if you don't already, pull up your Kruskal-Wallis test. You can go and download it from the Earthworms lab and use that. But we're going to actually go here, and we're going to rename this Kruskal-Wallis, just so that we know exactly what we're doing. So what I'm going to have you do is write mesic 1 through 5, down below xeric, 6 through 10. And so I just realized I spelled that wrong, but once again, this is what we're going to be covering, is we're going to be using all the plots of the 3 transects to get this. And make sure you don't do the same mistake that I did. It's an X. So we're going to be going back over to the data here. And we're going to go underneath our first transect. And we're going to be doing a formula. We're going to do equals count. And so underneath, right underneath species 25 for the first column, you're going to do count. And you're going to grab all the data here. You're going to close that up and click enter. And so what this is doing is whenever there's a value for a species, it is counting that as 1. So basically for plot 1, it is calculating your species richness. It's calculating how many different species there are. Not the total number of the actual individuals, but just what species there are. So to double check that, you can always go and count each value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it counts, it checks out. You can also always just highlight it, and down here it'll tell your count, so 9. So you know the formula is working. So all you have to do now is go here, drag that formula for the rest, and it should calculate for all of them. It doesn't hurt to always just check one. You double click, make sure it's grabbing the right information. It is. Click enter. So what we're going to be doing is we're going to be doing that for each of our plots. So we'll go down here once more, equals count. We're going to grab the values here, bringing it down to 25. close that, 7, double check, count is indeed 7. So it checks out, the formula is working. We'll go here and we'll check a random one here. It's grabbing all the right values, so we're good. Make sure when you double check and you have this, not to just click somewhere. If you click somewhere, oftentimes it might try to add that cell to your formula, which you don't want. So I just realized I skipped transect 2, but you want to make sure to do it for all 3. So you're also going to go here. So you're going to go equals count. Double checked, 9. And then we're going to go and grab this little box down here and drag it. We'll double check, make sure it's grabbing the right values. It is, so it checks out. So now what we're going to be doing is we're going to go back up to transect 1, and we're going to grab the data for 1 through 5. We're going to go Control C up here, and if you just do Control V, it'll leave zeros. That's because it's a formula, and so right now it's trying to calculate that formula, and it doesn't know because it's in a different sheet. So you don't want to do that. When you paste it, you want to make sure to actually right-click and paste it as values. So next, we're going to grab the data for 6 through 10. Once again, copy and paste, and we're not going to put it here because it's not 6 through 10 is for this one. So make sure that you don't do that and that you actually paste it where it belongs. And so all we're going to be doing is, once again, 1 through 5 for each transect and 6 through 10 for each transect. We'll go over here. See, once again, if you just do Control V, it doesn't work. So make sure that you do values. Now we're going to do 6 through 10. Copy. Right click, paste as values. And then once more for transect 3, 1 through 5. Paste as values. And then finally 6 through 10. Paste as, oh, I made my own mistake and forgot. And so I gotta delete that. If you do mess up, it doesn't hurt. You see it's no longer copying it. To go back and copy. So especially when you're going back and forth and copying, pasting, it can be really easy to mess up and just do Control V like I just did. So just make sure to really stay on top of that and that these numbers make sense and that actually matches up to what you're copying. So once you do that, if we recall that when we go into our Kruskal-Wallis test, it's set up in columns. So what we actually want to do is turn these around. So if you grab this and you copy it, you go below and you do paste special, just like we did for the XY plot. We're going to do transpose, and it will flip it around. And it's always good to double check to make sure that it's actually following. So 9, 9, 10, 8, 9, 9, 10, 8, 5, 6, 8, 6, 5, 5, 6, 8, 6. Yep. So everything works and it checks out. So you want to actually pull up your Kruskal-Wallis test. And this is the default data, so we do not need that. You can go ahead and delete that. Here, we'll write our messic 1 through 5, xeric 6 through 10. And all we're going to do, because we just made those labels, all we need to do is copy and paste this. So Control C, and then we'll go over to our Kruskal-Wallis. and paste as values. Very important to do that. And so as you can see, this test calculates our p-value. Your p-value will be different because you're going to have different numbers. The importance here is that you're going to be taking this p-value, and I want you to tell me what this means to your data. So we all know that because this p-value is low, it's lower than 0.05. I want you to tell me what that means, which I've already told you guys in the previous labs what it means when you have a certain p-value, whether it's causes for a fail to reject the null hypothesis, or if you reject the null hypothesis. So in this case, the null hypothesis will be equals and the alternate will be not equals to. So if you fail to reject the null hypothesis, that means that you have to keep it, meaning that these two samples are not significantly different, they're equal. If you reject the null hypothesis, that means you're accepting the alternate, which means it's not equal, meaning that there is a significant difference between the data set. So because my p-value is less than 0.05, we will reject the null hypothesis, meaning that there is a significant difference between the two data sets. If you're confused, because just looking at the numbers here, you might not know which one actually has the higher species richness, alpha species richness. You can always just highlight here, see the sum. So that one has 125, and this one has 104. So because the p-value was less than, which I'll just write it out, less than 0.05, this number is significantly less than this, it means that there is a significant difference between our data, or that we fail, we reject the null hypothesis in favor of the alternate hypothesis, meaning that they are not equal. And so the mesic is significantly higher, has significantly higher species richness than the xeric. Your data will be different, but this is just kind of an example. So what I'm expecting to see is basically that what I've been talking about, that explanation of the data should be said within your discussion, explaining what it means. However, in your results, you need to write what the p-value was, as well in the abstract. If you're looking at the abstract grading rubric, on it, it would say that you need to include your statistical test. That means in it, your abstract, you need to talk about the p-value and basically what it means. So you would say one of your sentences in your abstract would be that the mesic is has significantly higher alpha species richness than the xeric, and then you put in parentheses that your p-value was less than 0.05. If that's the case, you might get a higher p-value in which that there's actually not a difference. So it's all depending on what you get. But basically what we've done is we've covered this second part, and make sure to include everything that I just said. If I know it can be a little confusing talking about stats, so if you need to rewind that and listen to what I said a couple of times to better understand what I'm saying, that is perfectly fine. Just make sure that you include it where I said you should, and we got the second part done. All right, so my mic cut off when I was doing the third one, so I'm gonna redo it. So hopefully, I think everything with the second portion of this went smoothly. So we're gonna pick up right going into the third part of your data analysis, which is gonna be the species area curve. We're gonna be doing something kind of similar in regards of doing counts like we did here, except what we're gonna be doing is we're gonna be starting off counting how many original species there are, and then for every new species, it gets added to the total count. So I'll show you how to do that in a second. Something I like to do first, it makes it easier in regards of seeing new species, is putting this to no fill, and then going through and everywhere where it's 0.0, actually removing it. Things such as 0.3, you still want to keep. because that means that in one of the transects there still was a presence of it. So it's important. Um, However, all these zeros are not. So to make your life easier, I would make sure to go through. You can pause the video now and just take all the 0.0s and remove them. Now, something before you do that, um, if you notice from the trend, you'll probably have a lot of species up here and then like zeros down here and then zeros up here and species down here due to how the habitats were with species. Um, so it may look nice to go here and just delete all of this, but if I didn't catch it, there's an 0.3 there. If if I deleted this and didn't count that one, it would mess up the entire calculation. So if you do, I would just take it by row to make sure you're not actually deleting anything that's of value. So it might take a little bit, but it shouldn't take too much time. But just go through and everywhere it's 0.0, take time to just delete it real quick. It won't take too long, so don't worry so much. But when I show you how to actually do this, it is very important to have these cleared out because it'll make your life a lot easier. So once again, just making sure that you're not getting rid of anything with the actual values. So for example, I would leave this one. I would not delete that one. And I like to do it just the manual way. That way, you know nothing is getting messed up. So if you do decide, as I say, not to do it, if you decide to just do like a full thing, just really make sure that there's no values in there because it can really mess everything up. Like once again, if I did this, this would be wrong because you have that there. So there's a lot of places to end up messing up when doing this. So once you think that you have all of them, just quickly run through one more time to make sure that all these zeros are gone. It'll make your life a lot easier when you do this because I'll show you why. All right, so just like before, we're just going to get the count of the number of species in plot 1. So we're just counting where there's values. This is where, like I said, it makes it easier. There's no zeros now, so everything remaining is actual values. So we can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's down here, you'll put 10. And so now when you go to the second one, actually before doing that, it's always good to just double check. Hold on. By highlighting here and making sure that your count adds up, which it does. So now when you go to your second plot, you're not just counting how many there are again. If that was the case, we could have just do count equals and just rolled it all the way across for everything and done it that way. What we're doing is we're trying to look for new species. So if you look here, all of these so far has been there, has been there, has been there, has been there. This has not. So this is a new one. So that's 1. And then all these have. So it's just 1, so you would add it to the total. So that ends up being 11. And you're going to go through and do all of this. So all of these have been here. That's new. This one might appear to be new, but you got to remember you're going all the way back. So it was here. So that's not a new one. And then this is a new one. So in total, we had the 1, 2. So then down here, that would be 13. We'll go through again. These have been here. These have all been here, been here, been here, been here. So it remains 13. And you go through all these, nothing new, it remains 13 again. Now we're going to be getting two graphs, one for plot 1 through 5, and then one for plot 6 through 10. So when you get to 6, you're not going to continue with the 13. You're going to start all over again. And so you're going to get the count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously don't just copy these numbers. Your numbers are going to be different. So you're going to be doing what I'm doing just with your numbers. And your numbers should be different. So you should not be getting identical stuff that I'm getting. It's possible, but there's definitely going to be variation in the data. So keep that in mind. This is so that you can follow along with your data, not just copy down what I'm doing. So we're looking again to see if there's any variation of new species, which there isn't. So this number remains as 9. Down here, there's one new species, one new species, and then 2. So this goes to 11. All this remains. So you keep 11 again. And nothing is new here besides this one. So we end up with 12. So what you're going to do now is you should make a new tab down here and label it curve. And then I want you to do P-0, P-1, P-2, P-3, P-4, and P-5. Then down here somewhere you can go and do P-0 again, and then P-6 this time, 7, 8, 9, 10. So the reason we're doing this is because when we copy our numbers down below, it would have just been 2 sets of numbers, and when you're trying to make your graph, it may have gotten a little funky trying to figure out which one is the actual data. So by putting this letter in front, it clearly labels that this is a label, and so it can properly do our graph. And the reason we're putting 0, I will show you in a second. So under 0, you can put zeros underneath both. And then we're going to go back to where we just calculated these numbers. And we're going to grab 1 through 5. You'll copy it, paste it starting at 1, because it's 1 through 5. And then you'll go and you'll grab 6 through 10. And you'll paste it as well. So now we are ready to make our graph. So once again, we are creating a species area curve across an ecological gradient, except we're just doing it for each habitat. So we're showing the new number of species going across our transect going across the transect in the habitat. So there's going to be 2 different graphs. So all we got to do here is just go to insert. You can go to recommended charts and it should show it. We're looking for a line. If it doesn't show, you can just go here and just do a normal stacked line. Make sure that just right away I would label it that this is the messic. You're going to change this to the actual title it should be, with like a nice title, but just to label it so that you don't get confused on which one's which. And then once again, you'll grab this and do the same thing. And this one's Zurich. But once again, when you actually submit yours, you're not going to leave just messic Zurich. I want an actual nice title, as well as to include axes of what these are. And so the reason, going back to this, the reason I did 0 is because let's say we didn't, it would just be a floating line, which doesn't really show you a curve. So it's nice to, oh, I have to make sure to include here. It's nice to actually see this curve occurring rather than just a little line. So you can mess around with your axes titles, all of this. Once again, you're going to be taking these, copying them, and putting them, both of them, in your results, and each one should have its own description. You'll get points off if you don't have a good description detailing what this means, what each axis means. If you don't have proper axes titles, a nice title altogether describing what it is, those are all points off. But make sure in the description to talk about what P1, P2, P3, what that means. Obviously, them being the plots, and that 1 through 5 is for Messick, and 6 through 10 is for Zurich. So make sure that you include that in your results, and then you will actually discuss what happened and the difference here in your discussion. You're also going to be including this graph over here in your results, so don't forget about that. So you should have a total of 3 figures in your actual results section. You should write out what the results are, and you, in the discussion, you should explain what those results mean. And you can also refer to some of these questions that are listed below on exactly what, when you're writing your discussion, including some of those below, answering exactly what the data means and kind of the results all together, making it all come together, and so that your discussion is a nice piece that brings together everything that you've been researching and the significance of it, and just future studies, what you could have done different, everything checking off what's on your actual grading rubric. If you have any trouble with any of the figures or tables, if you need kind of a background refresher, if you click here, it'll actually bring you to one that explains everything and what you should have. And always refer back to the writing lab report module for your actual lab reports. Your grading rubrics also within there. So if you go here, this one I'm talking about, if you click on here and go through the exercise, it'll tell you everything. It also has the grading rubric that I use. So make sure to just follow everything on there and you will be pretty much set. So once again, we covered everything that was listed. I'll go back to it real quick. Down here, we covered the 3 different things that you need data-wise for your lab report. If you have any questions, make sure to ask me, send me an email, and make sure to keep on track of all the due dates that I listed originally. And I think that's all we have for today. Once again, keep an eye on those due dates. Any questions, ask me. I think I made it pretty good so that if you just follow along using your own data, it should be pretty easy to do this lab. And so that's all I have for you guys today. We do plan on meeting face-to-face once again the following week, but any updates on that I'll get during this week. And so keep an eye on your Canvas inbox as well as your emails to be up to date with what we're doing in regards to lab next week and just any updates whatsoever. So that's all I have for you guys today. Thanks for sitting through this entire thing, and hopefully you guys understood everything. Thanks.